Good morning, folks. The last thing we did was page 4b, where we derived the formula for delta equals ln of 1 plus I, and it's also equal to minus ln of 1 minus d. Today I'd like to teach you lots of different stuff that's not in your notes, so you'll have to take notes on a separate piece of paper, please. And I also want to talk about the writing assignment today. Okay, so the first thing I want to do is recap what I did very, very quickly. I had said last time that delta of t is equal to a prime of t over a of t, and it's also equal to d dt of ln of a of t. So suppose I have capital A of t. Suppose you have capital A of t is equal to k times A of t. Then delta of t is equal to a prime of t over a of t also, because a prime of t is equal to k lowercase a prime of t, and a of t is equal to k a of t, and because the k's cancel, you're still again left with a prime of t over a of t. So when you are given capital A of t, you can do exactly the same formula that you would have done before. So I want to say this equals d dt of ln of a of t, like so. So take, for example, I want to lower this volume for just a second so there's no echo. Give me one moment, please. Okay. Let's say that capital A of t is equal to c, which is a constant, a to the t, b to the t squared, d to the c to the t. Find delta t. That's the question. So the trick here is take the ln of everything. So you would get ln of a of t equals how do we take ln? So it would be ln of this whole mess. Ln of c a to the t, b to the t squared, d to the c to the t. And now you separate it using the log rules. So this would be c, ln c plus, ln c plus, how do you take the ln of a to the t? T ln a plus, how do you take the ln of b to the t squared? T squared ln b plus c to the t ln d. So delta of t is equal to d dt of the above. Let's take the derivative with respect to t of this above statement. I'm using this rule. This thing right here. So let's take the derivative with respect to t of ln of capital A of t. Go. Ln of c, that's a constant. So the derivative with respect to c, right, with respect to t is 0 plus
t over a.
ln a is a constant. Ln a is a constant. So what is it? Ln a plus, right, ln b is a constant, pull it out, times 2t plus ln d is a constant, pull it out. What's the derivative of c to the t with respect to t? C to the t, ln c. Right, and you're done. That's delta t. So look how easy it was when we first took the ln and of everything and then took the derivative, as opposed to doing the other formula, which is a prime of t over a of t, which would have been more painful because of all this. I would have had all these product rules here, and that's painful. Okay, next example. If you have a constant force of interest, delta, I won't write of t because it's constant, equals 0.042. Calculate the present value of a payment of $5,000 to be made in 8 years. What do you say? What do you think? What kind of interest is this? Compound interest, right? Why? How do I know it's compound interest? Sorry? Yeah, constant force of interest. So that implies compound interest. Implying compound interest. What's the formula for delta for compound interest? Do you remember? Excellent. So delta equals ln of 1 plus I for compound interest. You're going to memorize that, right? So the question here is the following. Here's time 0. Here's time 8. Calculate the present value of a payment of $5,000 to be made in 8 years. The question is, what is this value here? The present value. So what is A of t for compound interest? Do we know? A of t equals what? It's 1 plus I to the t, but that's not going to help me right now unless I want to change my delta to I. Right? So what if I don't want to do that? So this is helpful to me if I want to first find I and then plug it in.
So e to the integral from 0 to t the delta?
A of t is equal to e to the integral from 0 to t of delta of r dr. Tell me, is this necessary in the case of compound interest? Do I really have to do this if delta is constant? Let's plug it in and see what you get, okay? This is what you would do for any delta, for some strange delta, for some strange a of t. But this is not strange. This is compound interest, right? So we're going to come down to a derivation, and then we're going to use it every time we have compound interest, okay? So let's do this. This is equal to e to the, it's not delta of r anymore because delta of r equals delta, right? Constant. So let's write here, delta of r equals delta. So e to the integral from 0 to t of delta, I pulled that delta out, dr. So 1 dr, right? So I just get e to the delta t minus 0 here, right? Like this. So this is just e to the delta t. Finished. Every time I have compound interest, it's going to be e to the delta times t. This is a multiplication in the middle, right? E to the delta times t. So let me do that right now. A of t compound is equal to e to the 0.042 times t. E to the delta t, finished. So therefore, v of t is equal to 1 over a of t, which is equal to e to the minus delta t. Right? What is v of t again? Do you remember? What is v of t? Discount factor, right. The discount factor, which is always equal to 1 over a of t. Okay, so now what shall I do here to go from here to here? Multiply by v of t, where my v of t is equal to e to the minus 0.042 times t. My t is 8. I'm almost there. I also need a 5,000, deal with the 5,000. So this amount right here at time 0 is equal to 5,000 times e to the minus 0.042 times 8. Can you get me a number, please, so we can wrap up this problem properly? And then I want to do the same problem with i's. What did you get?
3,573.
3,573.12. Yep. So this whole problem was done not using I, but using this method right here. This method. I could have also done it using I. Method 1, let's say. So first I would have to find I. Let me do it right here. Method 1. A of t is equal to 1 plus I to the t. What is I? You guys told me that delta is equal to ln of 1 plus I, right? So why don't we take e to the delta equals 1 plus I? Let's write it here. Delta equals ln of 1 plus I, so e to the delta equals 1 plus I. Therefore, I is equal to e to the delta minus 1. The minus 1 is on the bottom. E to the delta minus 1. So can you get me the I that goes with this problem, please? What is I? E to the 0.042 minus 1. What do you get? 0.04289. Thank you. And then the present value is now equal to 5,000 times 1 plus 0.04289. That's your 1 plus I raised to the minus 8 power. Does that make sense? And you better get the same answer, right? 3573.12. So that is the other method you could have used. Same answer. Same answer, of course. Any questions regarding this? Okay, next problem. So what should we call this? This was page 4C. And page 4D. 500, new example. 500 is invested at t equals 15 years. Delta equals constant equals 0.06 per year. Determine the accumulated value at t equals 25 years. So again, delta equals constant. Quickly, what does that mean? Compound interest, right? A of t is equal to e to the delta times t. So, timeline, time 0, time 15, time 25. 500 is invested at time t equals 15. Determine the accumulated value at t equals 25. What shall I do? Do I have to go back and discount it to time 0 and then move forward? We decided that for compound interest you never have to do that, right? So what shall I do in going from here to here? Again, two methods. You could deal with I or you could deal with delta. So first let's deal with delta. So first method. So the accumulated value here, accumulated value of some k at time 0, right? Whatever this is, I don't really care, of 25 is equal to 500. I'm just going to go from here to here. So what is this A of t to go from here to here? What do I multiply by? 10 what? What? What should I do?
1 plus I to the 10th.
Okay, that's one method, right? That's the I method, but right now I want to do delta. I'll come back and do I in a second. E to the delta times 10. That's it, done. So that's 500 e to the 0.06 times 10, which is 500 e to the 0.6. And what do you get? Where's your calculators, folks? $911.06. Okay, what if I wanted to change it to I? Then what? So this is the only formula I know, right? Delta equals ln of 1 plus I. If I begin there, it's just one more step. Memorize this guy, right? Delta equals ln of 1 plus I. So e to the delta equals 1 plus I, and I equals e to the delta minus 1. So let me find the I for my sake right here. So I equals what? Help me, guys. E to the what? E to the 0.06 minus 1. So what do I get? 0.0618. Okay, I'll leave it at that. So 500 accumulated value equals 500 times 1.0618 raised to the 10th power, which is 911.06. Same answer, of course. Hey, you have choices. Does this make sense? Yeah.
Is I always going to be greater than this delta?
Yes. I is always greater than delta. You'll see that in maybe today, maybe next time.
I have a question.
Yes.
So the e to the delta t always work, like, or is there?
For compound interest, e to the delta t is always equal to a of t, only for compound interest.
Okay.
If it's not compound interest, then where are you, my friend? Who am I speaking with? Hi. So if it's a different accumulation function other than compound interest, then you would say a of t equals e to the integral from 0 to t of delta of r dr, and then go and integrate that, because it's not going to be a constant.
Yeah, that makes sense. Thank you.
Okay, next page. Okay, so let's talk about this now. I want to take a new page because I'm going to need lots of room. Let's call it 4E. So we said before that for strange accumulation functions for a of t, strange, and by strange you know what I mean, right? Not compound, right? I would have to do strange, meaning not compound interest. If I had k at time t1 and I wanted to find what the value was at time t2, I would first have to go like this. Multiply here by v of t1. This is the discount factor that brings me back to 0. And then grow this thing again, a of t2. Agree? Now I have to put this mess in terms of delta, because that's what they're going to give me. So how about I go like this? Accumulated value at t2 is equal to k divided by a of t1, because v of t1 is 1 over a of t1, right? I'm trying to gear up to you doing your written assignment. So I'm in baby steps spoon feeding you, okay? K over a of t1. And then that would be the value at time 0. And then I will grow that. So a of t2. Agree? So now let me put it in terms of integrals. So this would be k divided by, what's the a of t1 in terms of integrals? E to the what? Integral from what? 0 to t1 of delta of r dr. Notice I just don't write delta now because it's not constant, it's some strange delta, times e to the integral from 0 to t2 of delta of r dr. Do I really need these two different things here? Can't I combine them? So this is equal to k e to the what? How about like this? Integral from 0 to t2 of delta of r dr minus integral from 0 to t1 of delta of r dr, which is just equal to k e to the integral from t1 to t2 of delta of r dr. So this is a powerful result, right? You don't have to take it back and then bring it forward if you're using e to the integral from t1 to t2. So I'm saying take your k from here and then just go e to the integral from t1 to t2 of delta of r dr, and that is kosher. That is just fine. Follow me. You don't have to first discount it and then bring it over, because this is doing all that in one step. Let's do a problem. So somewhere here I should write, before I do that, somewhere here I should write a formula that says this, okay? 0, T1, T2. To go from here to here, A of t is equal to e to the integral from t1 to t2 of delta of r dr. And let's put that in a box and let's memorize that. And then let's do our example. Example. Deposit $1,000 at t equals 3 years. Delta of t is equal to 0.3 minus 0.03 t. Find the accumulated value at t equals 5 years. So what are you going to do? You're going to use our new formula. If I was doing this otherwise, I would have to first bring it back and first discount it back and then grow it, right? Because it's a strange a of t. But I don't want to deal with that. So I'm going to use my new formula, which says the accumulated value is equal to 1,000 e to the integral from 3 to 5 of delta 0.3 minus 0.03 r dr. And then somewhere else I'll go and figure out that integral and come back and finish this, right? So let's do it here. Integral from 3 to 5 of 0.3 minus 0.03 r dr is equal to 0.3 r minus 0.03, can you see? Okay, minus 0.03 r squared over 2.
Wait, is it saying 0.3 or just 3?
Right here,
Yeah.
0.3.
Okay.
0.3 r minus 0.03 r squared over 2 from 3 to 5. So let's plug in 1.5, because 3.3 times 5 is 1.5, minus 0.015 times 25, minus 0.9, I'm plugging in 3 now into here, minus 0.9 plus 0.015 times 9. So 1.5 minus 0.9 is 0.6 plus, actually minus, what's 25 minus 9? Minus 25 plus 9 is 16 times 0.015. So when I clean up this mess, I get 0.36. So go back and put that in up here, equals 1,000 e to the 0.36. Can you get me an answer for this, please?
Yeah, that was
1433.33. Thank you. Let's just separate this. Any question? So then, because a of t is equal to e to the integral from t1 to t2 of delta of r dr, I can say that the discount factor then, v of t, is equal to 1 over a of t, which is equal to e to the minus integral from t1 to t2 of delta of r dr. If you know one, you're going to know the other because this is just the negation in the exponent, right? Everybody good?
I have a question.
Yeah.
Since we know delta of t is constantly decreasing, wouldn't that also mean that I is constantly decreasing? So we could say this is a simple interest problem? No.
What do you want to do? What?
Could you say this is a simple interest problem since we know that delta of t is decreasing?
But what is delta t for simple interest?
E,
It's equal to a prime of t over a of t. So just because you see something similar doesn't make it simple interest, right? What is the formula for delta t for simple interest? Let's do it right now. If you don't have to memorize that, you just do it. Let's see, 4f. What is delta t for simple interest? So a prime of t over a of t, right? Where a of t is equal to 1 plus it, correct? So a prime of t is I over 1 plus it. Now that is not the delta I saw in the previous problem, so I cannot assume simple interest. Get it? Okay. So, I have a couple of other problems I need to do, but I also need to talk to you about your written assignment. So let me do that first, and then if we have time, we'll come back and fill in this page, okay? So 4G, sorry about all these. Something similar to your written assignment, let's see. So this will help with written assignment. It'll help a lot, okay? So let's say that you have two delta of t functions. I have delta 2 of t and delta 1 of t. Suppose delta 1 of t is greater than delta 2 of t on some 0 t. This implies that a1 of t is greater than a2 of t because e to the integral from 0 to t of delta 1 of r dr would be greater than e to the integral from 0 to t of delta 2 of r dr. So I'm saying e to the area under delta 1 is greater than e to the area under delta 2. Make sense? So let's take this following example. have these two delta functions and they look like this. This is fund 2. This is delta of t for fund 2. Let me label that fund 2. And this is delta of t for fund 1. And they happen to meet at T1. They cross at T1. And then this is some T2 right here. If this were the case, then you should invest in fund 2 from 0 to T1, because the delta t for the fund 2, the delta 2 function is higher from 0 to T1. And in fund 1, from T1 to T2. Note that A of T2 minus T1, the accumulation function that does this, 0, T1, A of T1, and then A of T2 minus T1 works for compound interest only. So here, in my case, 1 grows, so here meaning here for our example, okay? Our example, let's separate this out, okay? Because this is not our case. This is not in the case of our example. It only works for compound interest. My stuff is not compound interest. Otherwise, I would have a constant delta, right? So for our example here, 1 grows from 0 to T1, to T equals T1, according to A2 of T1. Meaning, to go from 0 to T1, I do A2 of T1. Since delta 2 is higher than delta 1 on 0 T1. And then, well, 1 goes from 0 to T1 according to consensus. So, wait, let's not finish it there. So we would have A2 of T1 at T1. And then, from T1 to T2, I need to discount and then advance like this. Take A2 of T1, which is the amount that you have at T1, and then bring it back. Let's draw a timeline. Zero and T1, and I have A2 of T1. So I want to bring it back by V 1 of t1 and then grow it to time t2 going this way by a1 of t2. So I'm saying that between time t1 and t2, the fund 1 function is higher. But if I have some value at time t1, this is not compound interest. So first I have to take this value, which is existing at time t1 because I grew it, and I need to discount it to time 0 and then advance it to time 2 based on the accumulation function 1. So I would have a2 of t1 divided by a1 of t1, because remember v of t is 1 over a of t. So I would divide and then advance times a1 of t2. That would be my value at t2. So let's write here discount, and then this one is advance. And this is what I have at time t2. Amount at time t2. Does that make sense? Or you can be a smarty pants and do the following. For h. Or how about this integral e to the integral from 0 to t1 of delta of 2 dr times e to the integral from t1 to t2 of delta of 1 dr. Because we just finished saying that this business will take care of the discounting and the advancing. Remember, we just derived that? So this should really make your written assignment doable now, understanding this. Are you with me? Any questions? What is your written assignment? I think it's like 1.12.10 or something, Mr. Valdez example, that one. Right? And when is that due? Friday? Oh, okay. Plenty of time. Any questions?
Our homework that was supposed to be due on Sundays with Wednesday, correct?
Your homework that was supposed to be due when? On Sunday? Is due when? Wednesday? Yeah, didn't I change the date already? Yeah, I changed the date. Yeah, the idea is not to make you crazy. The idea is for you to have the time to do what you have to do. Okay, we have time for one more example, so let me go back to that page 4F. Let's see, 4E. All right, example. Deposit 5,000 at t equals 6 years. Delta t is given by 0.1 minus 0.002 t. Find the present value of this at t equals 3 years. So what's the discount factor? We want to bring it back, right? Let me draw a timeline. Time 3, times 6. I have 5,000. I just want to know the present value of this 5,000 here. So what should I be multiplying by? V of t, right? Yes? What is V of t for this strange accumulation function? It's not compound interest. It's not. So what's the formula? How should I go backwards?
E to the integral of 3 to 6.
E to the,
Integral of 3 to
how about minus the integral of? Because I want to bring it back, so it's V of t, so it has to be minus integral from 3 to 6 of delta of r dr. 0.1 minus 0.002 r dr. So I have to go somewhere and do this now. So integral from 3 to 6 of 0.1 minus 0.002 r dr equals 0.1 r minus 0.002 r squared over 2 from 3 to 6. So 0.1 times 6 minus 0.001 times 36 minus 0.1 times 3 plus 0.001 times 9. Is that correct? You can correct me if I make a mistake, guys. So this is 0.3 plus minus, right? Minus 27 times 0.001. That makes sense. 0.3 minus 0.027, which is 0.273. And then go back and put this into the integral. So let's say here where e to the minus 0.273. So what do I get?
0.76109.
Did you times by 5,000? I bet it's times by 5,000, right? So let me clean this up a little bit. Okay, so what do I get? $3,805.46. I agree. Everybody good? I'm just integrating. Okay, and I guess this is a good place to stop, right? Okay. Tomorrow's office hours, you got my email, right? I have a meeting right before that I'm sure is going to run into my office hours. So please can we, if you need me, I'll be there at 5:30, not 4:30. Okay? If you need me. Have a good day, folks.